So more LTO 48 cell system testing with the car on the bench. So I've been looking at the IGBT Pre-driver, which is this board here, and you'll see at the moment the system is active on this car on the bench here. This light here indicates that the IMA is engaged and the capacitors are charged. This is the motor light here, so when I'm applying power the light will light up. So if I give it a bit of manual assist, you'll see the light comes on. Over here we've got the normal stuff, but the main thing today is that we're looking at the pre-driver, because we've been just trying to work out how to get rid of this dead zone. So thanks to John for his helpful comments there. And what I've decided to try in the first instance is what I was discussing earlier on. I worked out that the I'll just get a pen for this. Worked out that the wire here, this grey and red wire here, is the positive, and there's a negative as well from the IGBT filter capacitor connection. So that's where the HV goes into the IGBT module, and these wires are directly connected to those 2 points there. So the HV is being detected in this module here, the actual voltage, not in the IGBT, and then sent to the pre-driver. So looking at this board, then it was pretty obvious, easy to see that the circuit here with this red filter capacitor here was associated with the HV detection circuit. So all I've done there is I've chopped the connector and I've added in plus 48 volts from an isolated DC to DC converter, and I was able to get 5 volts from some pins over here. So basically when you switch the car on, it gives it an extra 5 volts and an extra 48 volts, and away you go. So this is now added on to our fake battery voltage. So the points here, we get the actual battery voltage, which might be 100 volts or whatever it is, and then actually what the pre-driver now sees is that voltage that we just mentioned, 100 volts for instance, plus the 48 volts added by the DC to DC converter. There's a resistor here. This is a 10k resistor across the converter. That's just to give it a load so it doesn't go out of spec and give a too high or too low a voltage. This is just a dummy load for the converter. So that is that basically, and as you can see the system has accepted it, no IMA errors, and the system is energized correctly, and I can control it with IMA CNC, so I can give assist and cause the light to turn on. So there's absolutely no reason now why that shouldn't be working. And if we look at the display here, it is actually reporting the correct voltage. So you can see the voltage just flicking back there, but the top line on the next screen when it comes on is the critical one, so you'll see that the voltage is approximately what we're expecting. So that basically shows that we can fool the pre-driver, which then subsequently fools the VPIN without doing any further modifications in the MCM. Because in the MCM I was using an op-amp buffer to add on the equivalent of 48 volts to the analog 5 volt, but now we don't need to do that. So if we put the plus 48 volt system into the pre-driver box, then that also obviously fools the pre-driver and the VPIN. But the question now is, does this have any effect on the dead zone issue that we've been experiencing? So what I need to do now is to box that up and put it into the car and test it basically. I can't really test that aspect of it on here because this isn't anywhere near a high enough load. This is just to see if the basic system works. So I need to transfer that back to a case, fit it in the car, which is a bit of a pain because you have to take the MDM out, disassemble the MDM to get the pre-driver box out and fit it in. But once it's in, hopefully that should be that, and that might then get rid of the dead zone, but we won't know until I've actually tested that.